supposed to graph each equation or inequality, and I have some suggestions for you here. Suggestion number 1, change it to exponential form. Number 2, solve your equation for x instead of y. Number 3, when doing your table, substitute numbers into y instead of x. We're going to do this backwards. And then remember that exponential graphs have horizontal asymptotes, therefore logarithmic functions have vertical asymptotes. If we look at this problem right here, here's the problem. We can't just put this into your calculator. Go ahead, try. Give it a little gander. You can't do it. There's no sense in you trying. You can't do it. I don't want to send you on a fool's errand here. So the suggestion here is, if you change it to exponential form, someone tell me how to change this into exponential form. Miranda. 3 to the y. That's correct. Three to the y equals x plus 1. Now, if you leave it in its current form and you try to get y by itself, you have to use a logarithm to do that, and you end up with the original equation, which doesn't help us. So we're kind of cheating here by saying we can get x by itself easily. If you get x by itself, you'd subtract 1 from both sides. You get 3 to the y minus 1 equals x. So I just did the first 2 steps. Step 1 was change to exponential form. We put a little number 1 here. Step 2, solve your equation for x instead of y. That's what we just did on step 2. Typically, when you have an equation, you make a little table and you put numbers in for x and it gives you numbers for y. Since we have this solve for x, we're going to be doing it the opposite. So let's make a little table here. You know what? I don't want to do this. This is silly. It's a waste of your time. What does the parent graph look like? Abort all steps 1 through 3. If you want to do it that way, go ahead. I think it's a waste of your time because I think you have enough knowledge to not have to do that. What does the parent graph for this look like? Does it have any asymptotes? Yes. Vertical. Every logarithm has a vertical asymptote. And unless you're told otherwise, that vertical asymptote is at y equals 0. Scratch that, x equals 0. The general curve of this looks like the following. It's real close to this vertical asymptote, comes up, hits the x-axis at 1, and then runs to the right real fast. This is the parent. Depending on your base, we have a base of 3 here. If it had a base of 10, it would make it grow faster to the right the bigger that base is. Still would cross the x-axis at 1. So for example, let's say that this one here was y equals log base 3 of x. Base 10, it might look like this. See the difference? It's going to the right faster, the bigger the base is. So for this problem, what does the plus 1 do to our graph? We know what the parent looks like. What does the plus 1 do to our graph? We learned that in chapter 3. Miranda, you seem to be on top of things today. The whole thing translates left 1. There's no other numbers to speak of in this problem. That's the only thing that's changed. So your vertical asymptote that was on the y-axis is now to the left 1. So x equals -1 is the vertical asymptote. Your curve was crossing the x-axis at 1, but you move it to the left 1, it's now going to cross it at 0. So your curve looks something like this. You're not drawing it perfect, but you should show where it's crossing the x-axis fairly well at 0, 0. If you know the parent and you know your transformations from section 3.2, then you'll find this is much simpler than following those 4 ridiculous steps. Questions? Number 2. This has a base of 2, whereas the last one had a base of 3. So just to give you perspective again, you don't need to write this down. If this is what a base of 3 looked like, a base of 2 is not going to go to the right quite as fast. It's going to be a little bit slower. We have no other numbers in this problem, therefore it has not been translated left or right. It's not been translated up or down. It's not been stretched or shrunk. It's not been reflected. There's no other numbers. It just says you're supposed to shade below the curve. So you put your vertical asymptote on. It's on the y-axis. That's x equals 0. Draw your curve. It's crossing the x-axis at 1. Picture is not to scale. Just should be dashed since it says less than. That's correct. Should be a dashed curve because it just says less than, does not say equal to. Make sure that you point out where it crosses the x-axis, so 1, 0, and then shade appropriately. It's less than, so it's shaded below. All this here should be shaded, which you can just use little segments if you want. You don't have to make the whole thing look shaded. That's it for the graphs. If you rely on the parents and your knowledge of transformations, it's real simple. One last problem, and then I will shut my pie hole. Example F. If the population of 100 bacteria doubles every 15 minutes, how long will it take for the population to reach 12,800? We're going to need a variable. Let's say that x equals the number of times that it doubles. And it says it takes 15 minutes for it to double. So once you know what x is, the answer to the question was how much time. You're just going to take 15 times x. And that's going to be in minutes. X is how many times it doubles. So if it doubles 1 time, it's going to take 15 minutes. If it doubles 2 times, it's going to take 30 minutes. If it doubles 3 times, it's going to take 45 minutes, etc. So it starts out at 100. How long will it take to reach 12,800? Anybody have any ideas for an equation for this? This is completely new for you, so it would be completely natural for you to be a little bit frightened. Snorlax. Yes, sir. Let me help you out on this. We're starting out with 100. We're supposed to double that. I think I said something wrong earlier. I was doubling the minutes. The minutes don't double. The number of bacteria is what's doubling. So if we have 100, after the first 15 minutes, it's going to double. So then you're going to have 200. And then 15 minutes later, it's going to double again, and you're going to have 400. 15 minutes later, you're going to double again, it's going to be 800. What am I multiplying by each time? 2. How many times am I going to multiply by 2? We don't know. That's why we have this variable. The number of times it doubles means how many times you're multiplying by 2. So this 100 is being multiplied by 2 to the x. We have no idea how many times we're going to multiply by 2. That's the whole point of a variable, to take place of an unknown. We're going to keep doubling this until our population reaches 12,800. You cannot multiply the 100 times the 2x because the 2 has an exponent of x. So we can divide both sides by 100, and we get 2x equals 128. Hopefully we can write 128 as a base of 2. 2 times 2 is 4, times 2 more is 8, times 2 more is 16, times 2 is 32, times 2 is 64, times 2 is 128. That's 7 2's. So this is the same as 2 to the 7th. Therefore, x is 7. It's important that we wrote down at the beginning what x stood for. It's the number of times that it doubles. So this is not the answer. The question says, how long will it take? Well, it's going to take 15 times 7. It takes 15 minutes for it to double. It's going to double 7 times. That's 105 minutes. Finished.